Mein Name ist Bösch. I'm a software architect at Prodyna, and we do a lot of cloud native business. So we are a member of the Cloud Native Compute Foundation, and the project I want to be talking about is a cloud native project, a truly cloud native technology, which is a database, so-called NewSQL database named Spanner. And the goal of today's talk is basically at the end, you should be knowing what NewSQL is and how it compares to NoSQL. And just in general, what we mean by horizontal scalability in the cloud on the persistence layer. I'm going to be talking about not just theoretical stuff, but we've been building one of the biggest transaction systems in Austria. And this started back in 2018. So this was a truly microservice architecture. So as you can see, it was built in the Google Cloud. It was having different services. They had to be highly scalable. They needed to be dealing with at least 1 million customers per day and up to several hundred requests per second. So it was the number one focus to have our services, our applications scalable. But we also wanted to have, we also had these non-functional requirements, which they build up. So we need to be highly available 24/7. There was basically no downtime. We needed to be very, very scalable. So we need to have dynamic load characteristics there. So when you think of customers that would join in the morning or in the evening, so we had peak loads where you have a lot of more requests. So our platform would have to deal with that kind of load. So you scale up and scale down to be most efficient. We also needed to be consistent, which means when one of these services was writing something to a database, so the other service would have to have this change to the database immediately. There was no consistency gap in between. So we really needed to have that always consistent, supported by transactions. And we also need to be a very high performant because we were embedded in many other systems as well. So, and we had a lot of different customers on the other side. So we need to be very high performant. So when you think of all these non-functional requirements building up in a cloud stack, what kind of database would you choose? I mean, if you think for it just for a second. And basically, you have to have transactions, right? You should be compliant with SQL also, but you also need to be highly available. And that is something that probably leaves very limited choices. And you probably would end up with one of the usual suspects. So you would be having an Oracle database or some MySQL or Postgres or whatever. And you would be hoping that this thing is just powerful enough that it can scale with the demand that you have. But luckily, we had an architect back then who was a bit braver, I would say. And in hindsight, he was right. He introduced a completely new piece of technology, which was Cloud Spanner. And I would just go one step back and tell you a bit about how it was introduced at Google. So because Google started with the search business, right, in the 2000s, but then their business model shifted a bit. So they got more involved with ads. And these Google ads had completely different requirements regarding storage. So it needed to have these high consistency guarantees. So what did they do? They went away from their original storage model, which was more like a big table, how it's called, and they moved to MySQL databases. But the problem with this approach is, in the beginning, if you have like fewer requests, it's all fine. But then the number of customers grow, you make more business. So all you can do is basically you scale your database vertically, which means you add more storage to it, you add more memory to it, you add more database, more CPU to it. But no matter what you do, there is always a limit to this model of scaling. So at some point you reach the limit, and all you can do then is, in the case of a read, for example, that you simply replicate. So you have a read replica of the other database, for example, and then you would be serving potentially double the traffic, but you still have the problem, what happens with consistency now, because these can have syncing issues, right, in between. And it gets even worse if you also need to write a lot more, because for write, you always have the bottleneck. It always needs to be coordinated somewhere, and it needs to be replicated. So you end up probably having your customers knowing about all these different databases, and you shard your data. So which means you will have the customers on one database, and you might have the orders in the other database, And the clients of this database, they now read to like compensate those transactions, right? So if some storage process fails, the clients on themselves need to revert it, have to have compensating transactions and these kind of things. So it's really cumbersome, and it's not something that can easily be done. And this is also what Google realized. And so it was so cumbersome for them to do this resharding and scaling with these MySQL databases that they started an internal project. And this was the Spanner project. So instead of having a SQL interface on one node, they started to invent something, so a SQL interface on multiple nodes. So it should abstract away the complexity, which is behind these multi-node systems. So making it completely like as a black box for the client, what's happening between, and it should feel like the traditional databases. Also to satisfy the customers, which were very used to SQL and all the convenience that comes with it. So the project Spanner was born then back in 2007. So they released a paper, made it public, available in 2012, the technology behind. And nowadays, this Spanner technology backs up more than 200 Google services. So all the services you might know and deal with every day, like the Play Store, Google Drive, Gmail, and many more. So, and in 2017, they added like a public interface. So you can use it now as a managed service using a REST API or gRPC interface. And this is basically what we did for our project starting from 2018. So we have been talking about a lot of this terminology already, right? So we have been talking about consistency, availability, and partition tolerance. And I just want to, get this straight. The CAP theorem is kind of limited in a way, but it helps us to think a bit about the trade-off you make in a distributed system. So the CAP theorem states that out of these three properties, you can only choose two. So you can either be consistent in case you have a network, like in case something in the network happens, but then you might not be available, so you might not respond to your clients. The other option is that you lower this restriction on consistency, but in case of a network partition that happens, you might not be available. You might not return consistent results, which means you would return stale results. Spanner is always consistent. So this is like one of the main properties of it. So this is what we needed for our project. We needed to have a consistent system. And at the same time, Spanner is so highly available, so they provide a very high SLA that even the inventor of this CAP theorem states that actually it's kind of a CA system because it's that high. And this is why some people say it messes with the CAP theorem. And also, since we're talking about strong consistency, there is this opposing model you might know from all these NoSQL databases or most of the NoSQL databases, where you have weaker consistency guarantees. So just think of a football game, for example, that was ended. The final scores are written into a database. So then, you tell the leader, which all the writes goes through a leader, and this reader replicates the data to the followers. But there's, as you can see, there's a time gap in between. And then you might have on different parts of the globe, you might have different observers, and they might read different states on the data. So you might have Alice, you might have Bob. And while Alice at some point earlier already knows that Bayern won the Champions League, Bob is still not aware of it. And there you can think of certain scenarios where this is not a big problem, like news sites. It doesn't matter if it's just a few seconds later or something, but this might be a huge problem for sports betting, for example. And it also was a huge problem for us. So we could not go with one of those technologies. Instead, when you think of Spanner, it is the complete opposite. Spanner is like the only database, at least to my knowledge, who provides external consistency, so strong external consistency, which means no matter on what part of the globe you're accessing the database, you get a linear order of all the transactions that happen. So everyone will receive the same order of transactions. This sounds trivial when we think of it as a single node system like the traditional databases, but it's quite unique in that field of distributed databases. So this really helped us not thinking about the data. So it could grow as we wanted it to grow, but at the same time, yeah, you have a consistency model behind that, basically is, yeah, you have no worries about. And of course, this happens across all replicas. So once it's stored, it's on all replicas. This is one of the preconditions that it's externally consistent. So, but what's behind this technology? What makes it so unique? And I have to rush over it a bit, but it's quite interesting. So the one thing is they re-implemented this kind of consensus protocol. And if you have a distributed system with many nodes, you need to have a consensus which data has to be stored and which data will not be stored. So the majority needs to agree on a state of the database. And this is what they basically did with their Paxos protocol. So this is something that also been used at Zookeeper, for example, but they completely re-implemented it to make it more efficient for their use case. The second thing, and this is probably the most important thing, they introduced the so-called true time API. So they have a notion of absolute time, which means all of their data centers are equipped with these GPS antennas, and they have atomic oscillators, which means they can limit the time skew. So all data centers basically have the exact same time. And this is what allows them to give them the global ordering of transaction. And to be more precise on this, so they actually have a time interval, which basically is an indication of this time skew that happened. So you can always ask if one transaction is already like persisted or gone, and with what certainty. Yeah? And if two transactions are being compared, the other one probably has to wait until this thing returns true, basically. So this is very unique, and I'm not aware that it is used anywhere else except for Google. And the third thing, what makes it that performant, that available, is that they run it only in their own data center. So Google is a managed service, the Google Spanner is a managed service. You can only use it like via public API. And it runs entirely on Google infrastructure. So it's high performance network. It's a lot of redundancy there. They do a lot of homework so that this stuff is really efficient. But how does it work under the hood, right? So if you're familiar with working with normal databases, it really feels the same way as normal database, but it's a bit different. So most of these distributed systems have the property of having like a key value store semantics. So the key basically determines on which node you end up. So if you have this simple singer table, so the first two singers might end up or might be dealt with the first server, whereas the next three singers are dealt from another server. And this so-called split boundaries, so basically the split where the distribution is arranged, this is entirely handled by Google. So you need to make wise decisions on how you distribute them. But basically, this is all happening under the hood. You just need to be aware that you do this stuff efficiently so that you follow some best practices on it. And all of this data is then like 3 times replicated, so highly available, and you can be pretty sure that this data is never lost. So we did a lot of advertisement now, but actually, how does it feel in practice? And back then when we used it, it was pretty new. So it had some kind of bugs, especially on the user interface. And there are also some pitfalls that you should know about when you want to use it. Like the first we stumbled across was that you're limited with the number of mutations that you can make. So if you think of a row that you insert in a database, and this row has, I don't know, 5 columns, for example, then this would count as 5 mutations to the database. So you can imagine you're quite limited in how much you can do within one transaction. So if you want to do bulk loading, and this needs to happen transactionally, this is a bottleneck. Also, you cannot just arbitrarily just mutate arbitrarily many stuff or update as much as you want. So there is this limitation on that side. And also heavy input performance can heavily influence your overall query performance. So if you have a lot of bulk loading going on in the background of the database, this can influence what your customers feel on the other side if they do read requests, because this can delay the query operations. Spanner always tries to optimize the workload. Like if you have like some kind of hotspots, you see the customers 1 and 20 are accessed very much. So they might be shuffled to another Spanner server so that they will be, it's faster accessible. So it also does some fancy caching in behind. But this shuffling, if it's a lot, like with bulk loading, this can also influence your performance. And this is also something we found out during implementation. So, and then you see these kind of characteristics, right? You see, you look at the database monitoring metrics, and then you see these very high CPU spikes. And these are the indication. So you're not recommended to go beyond 65 to 70%, because if it's getting higher, you might suffer with your request latencies. And this is exactly what happened to us, and where we needed to find some ways around. Also something to consider, I mean, it has become much better, I checked it, but by the time we did the implementation, we had very little help from the online community. It's a very new piece of technology, and there were only very few results if you needed help. But the good thing is that most of the drivers are available as open source, so you can at least debug them and go into technical problems if there are some. Yeah, and finally, this is like the list of bugs we faced in production with Spanner. So one of my favorite ones was that we tried to find the right balance between write and read sessions, of course, because it should be more efficient to use the write sessions. But when we did that, each of our transactions was delayed for more than a second, which is the optimum, the quite opposite of what we wanted to achieve is a high performance database. So the solution to this, and this is still the case, we had to use read sessions for write operations, which is quite spooky in my sense. Yeah, and then also some stuff like the sessions expired after 30 days because the certificates expired, and this was nowhere documented. So suddenly our workload started failing. Also interesting thing is, so we had this like promotions and vouchers we needed to have time limited. So we used the current date function, which defaulted to LA time. So it was active only 8 hours after they should have been active, which means, we got some calls during the night. And finally, since I'm approaching end, we can sum it up with, Cloud Spanner, I think, is a great technology. It has some downsides you need to be aware of, but if you go back, it tries to mitigate for everything, for all the shortcomings that NoSQL tried to solve from traditional databases, right? So if you think back in the 60s and 70s, this consistency was very, very important, and the correctness, but the availability because of lacking of that, I would say of the Web 2.0 and the number of requests was not that important. And these traditional databases still have a hard time on scaling dynamically. So the NoSQL tried to cope with that by giving up on the strict scheme and the SQL language itself and switching to this eventual consistency model. And as we've seen for many workloads, and still, if you go to what's happening now, or just take all the production loads out there, 70% still rely on relational databases. So SQL is still very popular, especially among developers. So most developers learn it at school as well. So there is now, we see this shift from NoSQL to this kind of NewSQL. And it's not only Cloud Spanner, there are plenty of technologies out there that can do, that basically have come some kind of similar behavior. And if you go to the other cloud providers, for example, and you look at AWS or also Microsoft, they come up with similar solutions, probably not that scalable and sophisticated as the Spanner solution is, but with other properties. So if you think of DynamoDB, for example, it's not a relational interface, but also highly scalable and can deal with dynamic load. So it's basically this, I use it, a database as a service. This is basically the references I've used for this presentation. They will also be made available to you. And this is basically this landscape of NewSQL that is available. And with that, I want to close the presentation. Thanks a lot for your patience, and I'm ready for your questions.
Thank you, Hannes, for your talk. We collected one question from the chat. It's how do you NoSQL databases compare to conventional relational databases in terms of performance?
So the question is about how the Spanner database or NewSQL databases in general compare to the traditional database. It's a very good one. Thanks a lot for this one, because I think I had a slide somewhere for this. Yeah, so if you do short-lived transactions, which means you go to an online shop, you ask for that particular customer, you get that customer object out of it using the primary key of that customer, then this database is highly efficient. So I can just give you some numbers. We had calls going into our system, then we had to do 4 database calls in a row, of course optimized for the primary keys, and all of the calls together, including the response, took us 30 milliseconds. So you can imagine you're like 5 milliseconds for getting one entity out of the database if you're accessing it efficiently. And then, having said that, we compared the Spanner database also to traditional databases in terms of full table scans. And there the result was, to say it euphemistically, I think it was horrible, because of course it cannot do it efficiently if there is no index on it. And so there's always the trade-off for all of these kind of ad hoc queries where you don't know how the result that you want to query on the database. So where you don't know the access pattern up front, the traditional databases are, from my understanding, way more efficient. But if I know the access patterns, then Spanner can be way more performant than Oracle database can be on these specific workloads.
Thank you. We have another question. Are there any use cases where you would recommend against using a NewSQL database?
Well, you have to know Spanner is not the only NewSQL database out there. So you can also have like CockroachDB, for example, and you can host that in your Kubernetes cluster and have it on premise as well. But having said that, for these NewSQL databases bring a lot more complexity. So at some point, it's much easier to use a traditional database if you don't expect your workloads or customer base to grow indefinitely, or if you don't expect to have very high dynamic load characteristics. So if that's not the case, then you might be better off using just a traditional database if it fits your use case, or even think out of the box with NoSQL databases like MongoDB, Cassandra, whatever. I would recommend NewSQL for your cloud applications. So where you have applications that are flexible, that are scalable, and you also want to have it backed up by a database that is scalable. And particularly for Spanner, you actually should use GCP, sorry. Because if you're in GCP already, it makes a lot of sense to use Spanner. If you're outside the GCP, it doesn't make so much sense because you introduce the uncertainty of the network to get there, and of course the latency to get to the Google network.
We have another question. How are NewSQL databases suitable for cloud native apps?
Yeah, so NewSQL is, as always, a very broad term, but in the case of Spanner, for example, it's a fully managed service. What does it mean for you? So all you do is you have an API to access the database, right? So your your application can be completely stateless, and you have a high performance backend you can rely on. And this high performance backend, as I stated out in the talk, is always consistent. So you can rely on it. If you even have like cloud functions or lambdas or whatever, and they are just going to the same sink, but this is always consistent, right? this is something that scales greatly. And if you need more, you just add more nodes. It's just a click of a button, then you get more nodes for serving your traffic. And this is why I think it's a perfect fit for cloud native applications. But you also need to be aware that this comes at a price tag. So the managed service always comes at a price tag.
Thank you. We got another question. Aren't there privacy concerns when we use those managed services? Is it possible to host those new SQL apps on premise?
Yeah, very good question. This was also one of the concerns from our customers, so the number one concern. To be GDPR compliant in the European Union, you need to host this stuff in the European Union. And Google has data centers all across the globe, and a lot of them are located in Europe. So some of them are Zurich, then Frankfurt, then you have Belgium, you have Netherlands. So you can choose the data centers in the European Union. So this was the number one concern, and Google guaranteed that they will not leave the data centers there. So if you believe that, I think I think it's acceptable. At least it was acceptable for the governance of the company I was working for, and they were pretty strict on this. But just using Spanner is the one thing. There are other services that you use with the cloud that are located in the US. And if you use some kind of advanced features of the database, for example, you need to be very careful what you're doing. So some kind of audit logs, for example, whatever. Logging is one of the major concerns. They can end up on US servers. So you need to make yourself familiar with these kind of things in order to be sure.
Okay. I think we're done with questions for now. If anybody has any more questions, you can ask them later to Hannes. He will be there in the single session afterwards. But for now, I'm going to thank you very much for your presentation.
Thanks a lot. Ciao.